Hello everyone, we're going to go ahead and go through this last section. We did do these problems in class. I just wanted to do it one more time to make sure we're all on the same page. This is also your last worksheet before we go into the review. So I want to make sure you guys can see all the types of problems. We're going to do one of each, and we'll try to do this as fast as we can. So find all the solutions to each equation in radians. This is specific unbounded. So that means we're going to look at from negative infinity to infinity. So we're going to look at our 2 and pi version. So my first triangle, I see its sign is negative. See, that's negative there? And if it's negative, we want to figure out when is sign negative in what quadrant. And sign is all students take calculus. All students take calculus. And see, we're positive on top. Positive. But we're going to be negative on the bottom. So let's go draw my triangle. Always facing away, always facing away. My sign is opposite over hypotenuse. So my opposite is going to be square root of 3. Square root of 3. Hypotenuse is 2. And we know this triangle is a 1, 2 square root of 3 triangle. So that's going to be 1, 1 being a negative 1 there. As we talked about in class, we know these triangles. So it's a special right triangle where 60 degrees is always next to the 1. And following this, we now know our first angle from 0 all the way over to my first angle. That's 180, and then plus the 60 here gives us 240 degrees. Okay, we can write this in radians. They asked us specifically in radians. So we count by 60s, and that's going to be theta is equal to 4 pi over 3. And since this is not bounded, we're going to write plus 2 and pi because our period for sine is 2 pi. Our next angle over here, let's go all the way around, all the way. So we are 60 degrees short, right, of a full 180, full 360. So that angle is going to be 300 for us. So 300 is 5 pi over 3, and again plus 2 and pi. Easy peasy. Okay. Our next problem is what if we're bounded? And these types of problems, you actually have to solve it first to figure out where to go. And I'm going to just solve them before where it gets cosine alone. And then I'm just going to kind of start the first one and then actually do number 4. So to solve for cosine theta, we're going to minus 2 to both sides. Turns out cosine of theta is equal to 0. Now, cosine is of 0 degrees. Cosine, 0 degrees. It's the side is opposite is 0, hypotenuse is 1. Well, if my adjacent is 0, not opposite, adjacent is 0, and my hypotenuse is 1, okay, so we could be over here at pi over 2. That's one possibility. And the next possibility, cosine is also 0 down here. So we're actually 3 pi over 2. So theta can be pi over 2 and 3 pi over 2. We go to the next one, so I'll set this one up. We're trying to solve for a sign here. So we get rid of the 4. We can divide by 4 to both sides. And we see that the 2 and the 4 divide out. So it'd be square root of 2, square root of 3 over 2 equals the sine of theta. Well, if my opposite is square root of 3 and my hypotenuse is 2, we know that triangle. And this is positive, so we can draw that on top. Sine is positive on quadrants 1 and 2. And my opposite is square root of 3. Hypotenuse is 2. Opposite square root of 3. Hypotenuse is 2. And we're left with a 1 and negative 1. We see that's a 60 degrees, 60 degrees. So our first angle is really just 60 degrees. Our second angle is 120. And rewriting this in radians, theta is equal to pi over 3 and 2 pi over 3. And again, these problems, they really only wanted between 0 and 2 pi. Okay, now these questions, again, to find all the solutions, do you see the details abound here? Nope, that means we're looking for all from infinity, from negative infinity to infinity. So we're looking at our 2 n pi versions for sine and n pi for tangent. And you can tell our first problem, sine isn't alone, a lot of stuff going on. So using algebra 1, so go ahead and solve for it. Let's get rid of some of these numbers. That's 4 is equal to negative 8 sine of theta. How to get rid of that negative 8? We divide the negative 8 to both sides. So that would be negative 1 over 2 equals to sine of theta. And now it's easy peasy again. Sine is negative in quadrant 3 and 4. Negative 1 and 2 and 2. Square root of 3. Square root of 3. That's negative, and we see that's going to be a 30-degree angle as our reference angle. Counting from 0, that's a little bit over 180, so that's 210. And on the right side, we're a little short of 360, right? This is 360, and that's going to be 330. Okay, they want us to rewrite this in radians. Counting by 30 degrees, so 7 pi over 3. And again, remember, this is not bounded, so we have to write 2n pi. And 330 is, we almost hit, oh sorry, 6, my bad, I'm sorry, that's a 6. Let me erase that. Erase that, that's a 6, I'm sorry. 7 pi over 6. And on the right side is close to 12 pi over 6. So we're 11 pi over 6 plus 2n pi. Okay. If you look at this problem, we have to get rid of the 4 and then the 8. Pretty easy. It's going to be 4 divided by 8 equals to cosine of theta, which leads us to 1 over 2 cosine of theta. Cosine is positive in quadrants 1 and 4. 1 and 2 and 2. 60 degrees. 60 degrees. Okay. That's going to be pi over 3 and 5 pi over 3. Done. Plus 2n pi. Plus 2n pi. Okay. Okay, let's start number 7. As you can see, there's actually a lot of stuff going on. I have cosine and tangent. So how are we supposed to get cosine or tangent alone to make this an easy solve problem? Just like back here, where we could just have sine alone, see with sine alone, or cosine alone, or cosine and sine alone. See, these are all alone. So there's a trick here, and we are actually going to get them both on the same side. Square root of 3 cosine of theta plus this to both sides, so it's plus cosine of theta tangent of theta equals to 0. Now, if you notice that they both have a cosine, so we're going to factor it out. Cosine of theta, we have left over square root of 3 plus tangent of theta is left over is equal to 0. Now, these special types of problems, we then have to solve them separately, just like in Algebra 1. The example, the corollary in Algebra 1 is if I wrote x squared plus x equals to 0, you factor out a common x, and we're left with x plus 1 is equal to 0. Do you guys remember that? And then you set each of these equal to 0, and we solve for them separately. So my two possibilities here, x is not only 0 here, but also negative 1. And if I plug in 0, that's 0 of course, but if I still plug in negative 1 to the problem, that also gives me 0. So that's what we're going to do here. We're going to set them separate answers. Cosine of theta is equal to 0, and square root of 3 plus tangent of theta equals to 0. You might say, Mr. How do I solve that? Well, look at the left one. Cosine is 0. When is cosine 0? Well, you can draw the triangles if you want. Cosine, that's 0 over 1. 0 over 1. 1, yes, and my third side has to be 1. And it turns out this is a 90-degree angle, pi over 2, and a 3 pi over 2 angle. Those are two answers, answer 1, answer 2. And we're going to look on the right side here with two more answers, minus square root of 3, minus square root of 3, and you'll see that tangent of theta is just negative square root of 3 over 1. Let's draw those triangles. Tangent is negative in quadrants 2 and 4. Opposite is square root of 3. Adjacent is 1. Opposite is square root of 3. Adjacent is 1. And a couple of these guys are negative. So we know this is a 60-degree angle because those O's are next to 1. And our final answer is 2 pi over 3, as well as 5 pi over 3, because this is 300 and this is 120. Okay, so the final answer, actually you have to write all these together. You write all these together is theta is equal to, well, let's try writing them in order. Our first answer is pi over 2, followed by 2 pi over 3, followed by 3 pi over 2, followed by our last angle, 5 pi over 3. Okay, so in this case, we actually are solving for two separate problems. Not only cosine, see cosine here, but also square root of 3 plus tangent theta. Let's do one more problem, like this. I see cosine, sine, they're all kind of mixed together, and I don't really know what to do. Well, let's just move everything to one side. Let's move everything to one side. And if I move everything to the left side or right side, it kind of doesn't matter, but I'm going to try going left. So I see cosine, so I'm going to minus my cosine over, so minus cosine. And we see, oh hey, there's a cosine here, so these are actually like terms. That'll give me a negative 3 cosine of theta. I'm going to plus my 2 square root of 3 cosine theta sine theta. I move that over there to the other side, so it's plus 2 square root of 3 cosine theta sine theta. And remember, since we moved everything to the right side, we are now equal to 0, nothing left on the right side. Now, just like our last problem, we're looking for things that are similar, identical, that we can factor out. And as you can tell, we actually have a cosine and a cosine here. So let's go ahead and take those out. Cosine of theta is equal to negative 3 plus, no, sorry, there's no equal sign. We're just factoring out negative cosine parentheses negative 3 plus 2 square root of 3 sine of theta. And just like what we did before, we have two possibilities. Let's go ahead and separate these possibilities out. Separate these possibilities out. Cosine of theta is equal to 0. And then we have negative 3 plus 2 square root of 3 sine of theta is equal to 0. Rewriting this, cosine of 0, let's use the blue here. We know cosine of 0, 0 over 1 is 0, 1. 0, 1. And that's going to be a 0, 1, 1 triangle. So we're at pi over 2 and 3 pi over 2. On my right side, let's solve for sine. So I'm going to add 3 to both sides, plus 3, negative 2, oh sorry, positive 2 square root of 3 sine of theta is equal to 3 divided by 2 square root of 3 divided by 2 square root of 3 sine of theta is equal to 3 over 2 square root of 3. I'm going to rewrite this knowing the square root of 3 is so I'm going to rewrite the square root of 3 on the bottom, multiply square root of 3 on the bottom to the top. And that gives me 3 square root of 3 over 2 times 3. Hey, that actually reduces to become square root of 3 over 2. And that's the triangle that we know, square root of 3 over 2. I'm going to draw the triangle up here. I'm running out of space. The sign is positive in quadrants. Wait, is that positive or negative? No, it's positive. Quadrants 1 and 3, square root of 3, and 2, square root of 3, and 2. Be 1, 1, negative on my left side. We're going to 60 degrees, 60 degrees. So our theta here is going to be pi over 3 and 2 pi over 3. So let's go right in order. Theta is equal to pi over 3 is my first angle. My second angle is pi over 2. My third angle is 2 pi over 3. My last angle is 3 pi over 2. Again, to be good at this, I would pause the video and try the problem yourself without looking at my work again and see if you can do it. Or you can just go ahead and try the worksheet that's already posted online. Okay. So now, if we look at this next section here, the problems got harder. And this is what we didn't get a chance to go over in class. And we're going to learn how to factor and rewrite these problems. So I see a lot of cosines going on. Too many for me to count. So let's move everything to one side and see what we have. If I minus a 2 cosine of theta, square root of theta, with my like term, we end up with a cosine square theta plus cosine, 2 cosine theta. And see this one here? We're going to plus 1 to both sides, plus 1 to both sides. So plus 1 is equal to 0. Now, that doesn't look like just cosine theta equal to something. But I want you guys to see that this is actually a factoring problem. And I'm going to rewrite this problem in my brain or on the paper here to make it look like a algebra 1 problem. If cosine was just x, if I just call this x, well, that's x squared. And this is a 2x. Do you see how I wrote cosine as just x? And that will make my brain a little easier for some of us, just as we first start these problems. Well, now it's just an easy factoring problem, where x plus 1 and x plus 1. Do you see that? We went ahead and factored the problem, so we have 2 separate problems. And now we have to go ahead and solve for these separate problems. Let's go back and write this in cosine. This is really cosine of x plus 1 and cosine of x plus 1. Well, just like in algebra 1, we make these both solve separately to equal 0. So we're going to do that. So cosine of theta, sorry, these are thetas. I should change the thetas. Plus 1 is equal to 0, and cosine of theta plus 1 is equal to 0. And we've seen these types of problems, just like what we did before in the same exact worksheet. Cosine of theta equals to -1 as we solve for cosine theta to get it by itself. Now, when is cosine negative? In quadrants 2. And that's going to be n3. That's -1 over 1, -1 over 1, -1 over... Sorry, that's -1 over 1. And my third side, if you do Pythagorean theorem, that's going to be 0. So is there really a height there? Nope. It's pi. So theta has to be pi for both these triangles. Okay, let's just do one more problem. We'll do this one. Looks a little messy, the number 13. Now, the goal is to get everything on the same side. And then I think I just need to move over this 3 here. And it's going to be equal to 0. 0 equals to 3 sine of theta minus 2 sine squared of theta minus 1. I'm going to rewrite this, so it'll be theta, 0 is equal to negative 2 sine squared theta plus 3 sine of theta minus 1. Now, as I mentioned before, I think it's easier in my brain to rewrite this as just x's, negative 2x squared plus 3x minus 1, and try to factor that instead. One of the methods for factoring this trinomial is maybe getting rid of that negative sign. I don't like that negative sign. It makes it a little harder. So we're going to rewrite this as 2x squared minus 3x plus 1. And now the way I factor is I write the possibilities to make the front number 2 times 1 and 1 times 1. And are there any combinations here? When I multiply them over, 1 times 1 and 2 times 1, does that add up to the 3 in the middle? And it sure does. 2 plus 1 is 3. So we're going to rewrite this as negative 2x and x. And we said 1 is going to be in the back. And that's going to be a minus minus. Why did I say minus minus? Because we needed to get that negative 3 in the middle. See this negative 3 right here? And if I multiply my values, negative x and 2 times negative 1 is negative 2x, we get that negative 3 that we were hoping for in the middle. Okay, so let's go ahead and rewrite this problem again. 0 is equal to negative 2 sine of theta minus 1 and sine of theta minus 1. And like we did before, we break this into two possible answers. 2 sine of theta minus 1 is equal to 0, and sine of theta minus 1 is equal to 0. Let's go solve for my last problem first. Plus 1, then we're going to divide this by 2 afterwards. So sine of theta is equal to positive 1 over 2. Sine is positive in quadrants 1 and 2, and sine is opposite over hypotenuse. We've done this before. 1, 2, 1, 2. Square root of 3 is my third side. That's negative, and we know it's going to be a 30-degree angle. And that leads us to my first angle being pi over 6. And the second angle, since I'm one short of a full pi, sounds like I'm crazy, is 5 pi over 6. On my right side, let's go ahead and do that one in blue also. Oh yeah, sure, let's use blue. We can change it. Let's use a different blue. Or that's purple. How should I know? Colorblind. So if I add 1, sine of theta is equal to 1. Now this is 1 over 1. And if I'm drawing a triangle, call this positive. Opposite is 1, hypotenuse is 1, opposite is 1, hypotenuse is 1. Well, 1, 1, 0 triangle leads me this is to be only pi over 2. Okay, pi over 2. So that's right, my answer. Theta is equal to, starting from least to greatest. So this one first, pi over 6. Followed by this one here, pi over 2. Followed by this guy here, 5 pi over 6. And those are my answers. Okay, I hope you found this helpful. If you guys need more help with this, definitely bring questions when I see you again. This will be on your final.